Welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Nwaka, and I am your instructor. Today, we'll be performing the design of this 8-story hotel building and all that. Now, this building has been for a very long time. That's because the version of the software we are using was not able to apply soil load, so it was put to a stop and all that. So on this new version of this software, we have modeled the basement wall and we have added the soil load on our previous video. So in this video, we are now proceeding into the building analysis and then the design. And then we have also modeled for the mat foundation on our previous video. So if you have not watched that, you can watch that video right down on our channel. Okay, that's fine. So beginning from this right now, before we then move to the design tab, we are meant to cut what they call FE strip for the mat foundation. So that takes me now to the story 0. Now you can see that the story 0, we modeled the raft foundation previously. That was the last video we did on this particular structure. Okay, you can see the depth of the foundation 750, which is the mat foundation 50. Although we are going to check if this depth is going to pass or not, or if it's going to fail, or if it will be able to carry the weight of this building perfectly. Okay, so with this now, once we are done with the modeling of this slab raft and all that, we will then move into the cutting of the strip, because without you cutting the strip, you won't be able to design your slab after you are done performing the FE analysis. Okay, that's fine. So with this now, to cut your strip, just go to modeling here and then come to this place here, FE slab strip here. Now on doing this now, this will display for you and all that. Meanwhile, before we begin, if you have not subscribed to our channel, please subscribe and also give this video a thumbs up. And if you want to see the other parts of this video from the part 1, which is from the CAD file, where we perform the framing and everything up to this stage, this video is a course video. Yeah, you can get it from our online store, Ekidel online store, which the bio is on our about page and all that. Or you check below this video description, you also see the link. Okay, that's fine. So with this now, we will then have to do what? Make sure we are on the X direction, because I want to cut through the X direction first, and then come here that says type of strip. Make sure you choose FE strip. FE strip is for any kind of mat foundation. You choose FE strip. So on this now, they will ask you 2 questions. Where do you want the result to come from? Is it from building analysis or from FE floor analysis? Okay, you can choose to choose building analysis. It is okay. You can also choose to use FE analysis. It is okay. For me, I want to choose building analysis. You will get the same results. Don't be confused about that. So right now, I would then have to do what? Make sure that this is on display, because I want to cut through from the beginning here down to the ending here. So since this is a boundary and this is also a boundary of the slab, I will choose this end of slab and end of slab. Okay, that's fine. So with this now, I am on S direction. Once you have done this, you then come to do what? Click on this here and then hold your control key to keep the line of the strip straight. Then go down here and then click on this side here. So with this now, we have just cut our first strip here, which is called S1. You can see that S1 was FE. You can also see it here. This FE simply means what? Finite what? Element what? Method. Okay, that's fine. So with this now, I'll just cut again. Now I have cut through this panel now. I will then go again and cut, hold my control key, click on this place first, come here, hold my control key, and then click here. So I've just cut few of the panels and all that. Okay, I'll come again here, hold here again and cut through here again, hold here and cut this place. Okay, make sure that your lines are straight. I'll come again now, click here, hold my control key and cut through this panel. Now I have cut through almost all the panels. You can see that I've cut through almost all the panels and all that. I'll now come and change to the Y direction. So on this Y direction now, I will then come again, click on this place here, hold my control key, make sure it is straight and cut through this panel. And I have cut through this panel here and all that. in our last video, I showed you guys how to model a raft foundation perfectly. Most of the videos I see here on this space, all right, YouTube, they model their raft foundation wrongly by using just one slab, which is a very bad way of modeling a raft foundation, because you won't be able to get correctly the reinforcement that is meant to be in a particular region. For example, this column might be this region of this column might be wanting to have a smaller size of spacing of your rebar because of the weight coming on the column. So if you just use just one slab to model your raft foundation or mat foundation, what happens is that you won't be able to get the actual um, um, area of steel that is meant to be used at that particular place based on the load coming from that column. All right. So make sure you divide your mat foundation modeling slab into different partitions, following the grid lines and all that. Just as I taught you on the last video on how to model this. Okay, that's fine. So with that, you'll be able to get the actual reinforcement suitable to carry the column load around the particular region. Okay, that's fine. So with this now, we have cut through this place now. I will then go to this other side to click here and then cut through this other side now. I'll come and click here. That's fine. And again, I will then come now, click on this place here, then come here and then click this one here. That's fine. And again, I will then come here, click on this here, and then come through this place here and then click here. That's fine. So with this now, we have cut through the X direction and the Y direction of our slab strip. So I'll then come and do what, click on what, close here. So with this, if you come to your 3D view, you won't be able to see the slab strip that you've just cut through, because it will only apply when you're performing the structural analysis of that foundation. All right, and all that. So now that we have cut through this, we have cut the slab raft and everything, we have successfully performed the full structural modeling of this video. So, sorry, of this structure and all that. Following that, this building started from 2022 and all that, but we were using 2018 version of this software to model. On reaching the foundation, we saw that there was the kind of what stoppage, because 2018 does not apply soil load. So we have to now remodel the building on 2022 version or 24 version of the software to be able to apply soil load. Knowing that here on Ekidel, we don't just teach you just to get views and all that. We want you to understand. That was why we had to place what a stoppage, because 2018 was not able to apply what soil load. But on this version of this in our software now, we are not able to apply soil load, which is on the part, I think on the part 19 of this video, of this training video and all that. Okay, that's fine. So with this now, we're now moving into what the structural analysis. But before then, we have to do what, edit our materials. Okay, now on editing material, we have to do what, go to analysis now. Materials, in the sense that you have to edit materials based on what, choosing your bar sizes, the kind of reinforcement you want to use, which you have to assume first, then also the concrete strength, all right, and all that. So with this now, on this place now, then click on what, building analysis here. Now on this, you can see that this place that says what, edit what, material and all that. Click on this place now and then come here. Let us choose our concrete grade first. I'll come here and click on this place now. Now on the concrete grade aspect now, I want to use what, grade 25. Okay, so I'll come here and click on this place here. When I click on this, put your eyes here, you will see the actual value here, knowing that we have two values here. One is what, cylinder, and one is what, cube. Okay, that's fine. So come here and see the actual what, the strength of concrete you're using. In this case, you're using what, 25. Okay, that's because it's a medium rise building. Okay, that's fine. So I'll come now and then click here, and then come now and then click on this place that says what, okay here. So on this now, we have now applied what, you can see 25, they have all changed. Then come for this what, grade of steel. Come here and choose what, grade here, choose anyone here and choose our grade of steel. Okay, and I'll apply this here. Now when choosing your grade of steel, you can see that we have several grade of steel. Don't always choose plain. Plain is for a non-structural element, like when you're designing for like let me say drainage that is not carrying much load and all that, you can use 25. Or when you're designing for like let me say a DBC floor, you can use grade 25. But for a reinforced concrete, start with grade 10 and all that. Now I have explained how to choose this a lot depending on the country you are like coming from. But let me just recap. If you're coming from countries like Nigerian, African country, where standards are not looked at for, always choose grade 10, lower grade of what steel. That's because most companies doing this steel does not manufacture that strength of steel up to 460 or 500. But if you're in a let me say countries like US, Canada, you can go ahead and use 500 or even more and all that. So in this case now, we are going to use what? 410. So with this, once you have choose 410 now, or you can try to use 460 and all that. But I want to choose what? 410. So on this 410 now, I will then come now and then click on this that says what? Rebar diameter, edit here. And I'll have to choose what? Choose the type of the bars I want to use, okay? In your own case, you might see that these places are all ticked. So you have to uncheck and pick the one you want to choose. For example, now this is a column. Column simply means what? I should choose what? I should choose your rebars. I want to start with what? Diameter 16 for my column. So that is the minimum you can start with, okay? Now, in your own case, you might be seeing this checked, okay? So just uncheck all these ones and start with what? 16. That's the minimum size of rebar you're meant to start with beams and what? And for columns. So right now we're on column now. You choose 16, 20, 25. Let me just uncheck that that's too big. Then for wall, we have a basement wall here. I'll choose again 16 to 25. So uncheck all these ones that you have and pick only these three. For beams too, the same thing too. I want to check this one and leave only this 16 and all that. Then for slab, I want to choose only Y12. That's for a superstructure. Then knowing that I have basement, I have mat foundation, which is still also a slab element or member. I will also like to use choose 16, 20, 25. But I will leave the 32 is too big. Then for my foundation, this is footing. We don't currently have part footing here, but I'll just choose. Let me just choose 16 to 25. Yeah, that's correct. We don't have roof slab. So I'll skip roof slab. Yeah, no, we have roof slab here. So I'll choose 10. I'll choose 12. I'll leave these other ones here, and I'll choose 16. We have a roof slab here. You're correct. We have choose 20. Correct. That's fine. Then for my links now, we have beams that will carry links. We have columns that will carry stirrups. So they are all under links. So I want to choose only delta 10 for my, which is Y10 for my, or T10 or H10. Or if you're in a country like Canada, this is called what? S10. So I can do what? Come here and choose what? This here, okay? Which is 10 for just my links. I'll leave other things here at default. These are for the work. I can choose to remove all these ones and choose beginning from 10. All right, because these are for the side walls. Sorry, for the this is for the rebars along the basement walls. Okay, which is are like links. Okay, so I'll start from 10. So once you're done with this now, then come here and do what? Say okay and all that. Now, if you don't understand what I did now, we have done many videos on how to choose what materials. You can watch other videos where we explain more about material, but I think I explained a lot here, which is also okay. I'll come and do what now. Click on what? Okay here. Now on this okay now, I'll come and do it okay again here. Now we are now done with what? Setting our materials. We have already applied all the loadings, wind load, everything, previous videos, okay? So you can watch that and get that right. So on this now, we then come now. Once you've done this now, we then come and click on this that says what? Analysis here. Alright? Because we are done with loading our materials. You can skip this this place here. Go to what? Analysis here. Now on this place now, you then come and do what? Perform what? Building analysis. Don't check anything here. Leave them as for default. And then click on this place here. Now, on clicking on this now, they will ask you two questions. You can choose to perform just the building analysis alone without the design, or you choose to perform the two at the same time, which is the what? Analysis stage, and then move to what? Design stage. If I check these two buttons now, All right, I don't have steel here, steel members, so I won't check steel. If I check these two now, just check it now. What it means is that I want to perform the building what analysis, all right, and then also proceed to what the design, all right, which most times it can take longer time, can take up to 30 minutes, all right, or 1 hour, depending on how big the building is, okay. But most times too, you can choose not to design it first, just perform the building what analysis first, and then later move to the design tab and design each of them, the column, the wall, or you can or you can even see an option that says design all right. So I will have to do what perform the what analysis first, which is more faster. I'll then move to the design stage and then design what each of them, or design all at once. But whichever one is still okay, you will still get the same result, okay. So in my own case now, I will not design it alongside with the what building analysis stage, okay. So I'll just uncheck this now and then come here and then click on what building analysis. By doing this now, it is only designing what it is only doing what performing the structural what analysis alone without the design. So I'll come now, which I will do design later on the design tab. So I'll come now and then click on what building analysis. On doing this now, it has started performing what the building analysis of this structure of this 8-story building, okay. That's fine. So with this now, I have to pause this now and then continue later because it takes time to run. I'll continue once it is done, okay. That's fine. Now you can see that it is still running, okay. It is still running. I will like on pause. If I see any warning, I will show you how to resolve that issue, okay. That's fine. Now if you see this warning that says being this and this are to be marked as what cantilever, we have already applied all this before, so just ignore it, okay. Because most time the software tends to mark a beam that you have already supported with a different beam. You want to mark it as what cantilever, so just ignore that. So I'll come here and say, they say, do you want to continue, do you want to automatically mark the above beam? Say no, else it will go and mark the wrong beam as a cantilever. So I'll just say no. So I think this is the only warning that you will see when you're performing your own analysis, okay. That's fine, except you didn't follow how we did our how I modeled that, okay. That's fine. So with this now, I'll continue again when I see any other error again, okay. That's okay. Okay, so you can see now that we have done with the building analysis, but first I want to explain something for you. You can see that this story drift here, mine is marked good and this is marked good. On every account, your story drift must not mark X, like showing red X. If it shows red, it means that what it means is that the load coming to the building is much compared to what the structural members can be able to withstand, and that will cause what, like tilting of the structure, just like the tilting Tower of Pisa and all that. So it will cause that kind of, because now the building is, if anyone is failing, all right, most times you can see that direction 1 will like pass, while direction 2 will be failing. Direction 2 is the vertical, which is the y direction of your building if you're looking from the plan view. Direction 1 is the x direction if you're looking for the plan view. So if direction 2 is failing and all that, it means that the building is moving towards that direction of what y direction of the building. If it's standing, is moving towards the y direction. That means that that building is not stable. And knowing that every structure is meant to be at what equilibrium, meant to be what stable, and all that, no matter how you are trying to be fanciful, it must, all the thing must come to center of what gravity, must be at what equilibrium, okay. That's fine. So in this case now, on every account, your story drift must be treated what good, right? If it is not, if your story drift is failing on any direction, it means that you should go and apply what more vertical members on the direction that it was failing, okay. I'll make a video about story drift later, especially, okay. That's fine. So with this now, I will then come and do what, say okay, because everything is okay here. Okay, that's fine. Now hold on for that. It will just display here. Once this this button shows, that means it's done, okay. You can see that what the building analysis was successful, okay. That's fine. It took what, just 3 minutes, okay. That's fine. So you can now come and do what, click here and do what, say close. So on this now, we have done what, the building analysis now. We can see that it is what ticked, but the design is not yet done. You can see the next tab is what, design tab, okay, which I will do later, okay. Design tab can be done later. That's why it is kept separate, okay. So after I'm done with my board building analysis now, I can now move to what FE analysis now, because I'm going to what enter into the what to also do what do this structure too using what FE what analysis too. Okay, that will be helpful what for the foundation. Okay, so I'll come now again and click here now FE analysis, yeah, floor analysis, which is what finite element method. So I'll come now. Yeah, I've already done this before, that I can see that it is all showing the but I'll just do it again. You can see that this is cancelled. In your own case, you see then you see all the floors showing what X, 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 and X. Okay, that's fine. So with this now, I will come here and click on the first story one, come here and click on what story two and all that. Also, listen very carefully. In your own case, this place here will be showing, will be able for you to click. Make sure you click on it. Mine is not showing because I've already done it before. Okay. Now make sure you click on this merge color and merge. Make sure you tick it. Tick it. Then on this place now, here will be showing one before. Make sure you reduce the factor of stiffness for your what for your slab to 0.25 at least, or 0.5, but it's best to use what 0.25. Okay, that's fine. So with this now, once you have done this and apply this, sorry, and check these ones and make sure you have ticked all these, like use your shift key and select all these ones. Then the next thing now is to do what here will not be clicked, so make sure you click on it. And here too might not be clicked. Make sure you click on it too. Once you click on these three things, 1, 2, and 3, okay, come here now and then do what start what the floor mesh analysis. Okay, I'll come now and then click on this place here. Don't leave this, don't touch anything here, leave it. Then come here and do what click on this here. Now on this now you can see they want to do what replace, because I've already done it before. They want to do what replace. So I'll come now and say what yes, but in your own case you won't see replace, it will just go ahead and then continue. So I'll come now and do what say what yes, replace the existing ones. So you can see that it is now running what the finite element what method of building analysis. Okay, that's fine. Most people can use this one alone, but in all essence you must perform this first one here that says what building analysis. Okay, that's fine. Okay, so right now it's not time to do what replacing everything, right? Generating the new results for each of the stories. Okay, that's fine. If your modeling is wrong, in your math foundation, you will be having errors, warnings of what degree of freedom error, that's DOF. I know that once you see that kind of warning, know that you have to go and remodel your math foundation. Okay, although there are better experienced way to go against that error. I know that, but I won't teach you that because that's for highly experienced people, for senior engineers. And knowing that Ekidel here, we train both younger engineers, students, and all that. So I won't teach you that experience way, because the student might not be able to have that level of experience to be able to go against that degree of freedom. That's DOF warning issue. Because once you have that kind of issue warning, on your design will not pass. In fact, you won't be able to pass that stage. You might have issues throughout that design. So, but I will teach you a different way to go like to go above that error. Okay, but that will be for senior engineers level. Okay, that's fine. Right now, it's going to now display the mesh, which I have to wait for that to display. Okay, that's fine. Okay, that's fine. So right now, you can see that it has now displayed the first mesh. Okay, I'll then come now and then say this is what it's now. This is trying to do what a load chase down. Okay, so this is the 11th floor. You can see that it's showing what 11th floor. It is doing what it's trying to chase the load down from the highest level of the building to the foundation. Okay, so it's doing what they call load chase down analysis. Okay, that's fine. So with this now come and do what click on the button and say what okay here. It then move to the what next floor, which is what 10th floor. Now you can see that it is done with what 11. You can see here story 11 analysis what completed. It now move to what story 10 and then continue again. Okay, so just watch here. Anyone that finishes, it will tick that one good. Okay, that will be marked good later. Just watch. Okay, that's fine. So right now it's now going to what story 10. Now you can see that story 10 now is now what's running. You can see here story 10 is running and that. So the same thing. You can see now it has now moved to what the next level. You can see here story 10 that moved again. I'll say okay again because it's trying to do what? Mesh to do what? To, okay, don't worry, let me show you. I'll now come and do what? Say okay now. Now, what mesh means is that it's trying to gather the whole structural effect that, like, what all your loads, your wind load, seismic load, every load you have added is trying to do what? Distribute the load to each of the structural members. That's beams and columns, to make sure that the loads are equally shared based on how they are meant to be shared. Because if there is any error on the load distribution, then the structure will fail on that particular area and all that. So you tend to make sure that the load is equally what? Distributed. Okay, that's fine. So now it's down on story what? Story 9. Okay, and then say okay. So it's trying to do that. You want to make sure that the load is equally what? Distributed, regardless if there is a smaller member or a big member. All right. It must make sure that the load is equally what? Distributed. It's not like in a real life. Let me say if you have a fat person or someone that is very muscular, and then you have someone that is very, very lean without muscle. Then you say, okay, since this guy have muscle, this guy should carry much load. No, it will make sure that the load is equally what? Distributed. So if that person if that member that is smaller in a size or section is given the same equal number of load, that member will fail. That means that member needs to be what? Need to like at least increase in what section. Okay, that's fine. So now we are in what? In story 8 now. Then say okay. So the same thing will happen, right? It will do the same thing till it get to the lowest level, which is story 1 and all that. Then it now chase load down to the foundation. Okay, that's fine. So let us hold on now for that to display for the next, which is story 7 now displaying. Yeah. Okay, is almost there. Okay, I would have loved to pause this video because I don't want to take a longer time, because the same step that you're seeing, since same thing, it will still go. Now it's now going to story 7 now and all that. You can see the story 7 here. Okay, so once after story 7 display, I'll pause the video to move to till we get to story 1. I will then come out on story 1 again. So I'll say okay here. Okay, so right now, pause the video right now until you get to story 1. But the same step it will take. If your modeling on any of the floor has issues, this thing will stop at that level. It will not continue. So you make sure your modeling is okay and all that. And you'll be having the error that says what? Degree of freedom. That's DOF error if your modeling is wrong. And majorly on the slab modeling. Okay, that's fine. So I'll pause this now until it gets to what? Story 1, and then I'll then continue again with you guys. That's fine. Okay, so right now we are on story 5. You can see that I don't really like to pause video because I want you guys to follow me step by step until you get to the last. Okay, so right now we are on story 5 now. Okay, let me just say okay and then continue again. Okay, it's coming up. Okay, so why it's coming up now, you can see that everything is going well and all that. Yeah, let me just continue again. Okay, now we are on story 4 now. You can see that story 4. I'll then say again. So it has chased the load down from the 11th floor down to story 4. We'll do this till you get to story 0. Okay, I'll then say okay again. It's now moving to story 3 now. You can see that story 4 performance analysis we soon show completed. Then move to what? Story 4. Okay, so to story 3 and all that. So the same thing until you get to story 0. That means that's chased all the load down and brought the load down to the foundation. So if there is any error on any of your story, this analysis will stop at that story, because it cannot chase the load down from any story that's having error. Okay, so you must make sure that all the stories are perfectly modeled. Okay, and all that. Okay, now it's going to story 3 analysis now, which is we are going there right now. Okay, so right now this is now the story 3 model, which is the mesh analysis, which is load chase down and all that. So it has not chased load down, it has chased load down to the story 3. Okay, we now move on to the story 2 now. I will now come and do what? Say okay now. It's now going to analyze for the story 2. Okay, so we do that till you get to story 0. We then move to the, but before we move to the math foundation design, itself, because we are design it itself, we have to go and design for the superstructure first, okay, before we can move to the math. Okay, that's fine. So right now it is now on story 2. Okay, story 2 now, which is we are left with just 1 and 0. Okay, so I'll come again now and then do what, say okay again, and then it will move to story 1 now, continue for story 1. Okay, so right now you can see that it is now on the story 0. You can see the mesh analysis now of the story 0. Okay, that's fine. So this is the mesh analysis of story 0, as you can see it just now, and all that. So with this now, so this is the story 1. So with this now, I will now come and do what, say okay here. Okay, that's fine. So right now it is now moving to story 0. So it has chased everything down to story 0, as you can see. So the next thing now say just to what, completed. So you see all these things now, all here will now be doing what, ticked good. So the total height of our story of our building currently is 35.38 meters, right? 35.38 meters high. Okay, and all that. So right there, you can see that it tend to now save all. Okay, so you can now see that everything now ticks good and all that. Okay, so this is how I expect your own to be. Make sure everything here ticks good. So with this now, we have successfully performed the structural analysis based on building analysis and what, finite element what, method of what, analysis. Okay, that's fine. So we are meant to proceed to the FE foundation analysis, which is the math foundation what analysis. But before then, I have to go and design for the superstructures and all that. Okay, that's fine. So with this now, I will then come back to make sure on my plan view I'm on story 1, because this story 0 is for the foundation. I'm on story 1. Okay, so I'll come now and click on what, story 1. Okay, with this. So with this now, to now begin with the design, I can still be on 3D view and all that. I can come to my design tab now. Okay, on my design tab now, on my design tab now, you can see that there is an option that says what, design all, or design each of the members, column, beams, lip slab, you can start. Okay, that's fine. So you can choose to design each of these things. The reason why they kept you for to like design each separately, because you might want to have just the column result and all that. So because of that, I can do only the column, okay, or beam or anything. Say, okay, so right now you can see that it says what, design all. Okay, so I have to now do what, click on this design all now. But don't forget, it will take time, because designs takes time a lot. Okay, so I'll come now and then click on what, design all, or I can choose to design the column alone or the beam alone and all that. Okay, that's fine. So I'll come and do what, say design all. So on doing this now, to display this for me again, you can see that again now. If I check this now and check this now, this thing was what displayed when we are doing what, the building analysis, right? This thing displayed, but we didn't check this. So right now I want to do design now. For design all, it will show this, now you have to check this once now, check this. Okay, check this again now, and then make sure you check this to a select bar if any failure. If there is any failure, it will choose the higher bar, which is T20 or 20. So I'll come again now and then click on this. Okay, so if there's any failure on the lower reinforcement, it will choose what, the higher reinforcement. That's why I'm choosing this. So on this, if I not do okay, it will do only the design. All right, so I'll now come and do what, say okay now. So on this now, it now begin what, the design of the building. Okay, beginning from what, from the column. This will take time, so I'll have to pause this video, else it might enter into 1 hour or 2 hours. Okay, now if you have a lower system with system capacity, it might take like up to 3 hours, or let me say 1 hour something minutes to finish up. Okay, but in one case it can take some minutes, but I have to pause it too, because I don't know how many hours or minutes it will take. Okay, but right now you can see that you have begin what, the design. You can see that it has ticking good, the columns that are filling. So it's down here, all the column 1 now is passing, it's tick good. Column 2 is done. Column 2 is, you can see there, it's tick good also. So you have to pause this now, because it will do this for all the stories. Okay, that's fine. So you can see that we are at 80 out of what, 200 and something. Okay, okay, let me just hold on for the column side to finish. Okay, but for the beam side, I will, okay, let me just continue, because I think this column tends to be faster, but I think this is just, okay, this is for all the stories. Okay, so let me just hold on for that to finish up. But make sure, know that the beams take longer time. Okay, because beams are always, they're very, very disturbing. It takes longer time than the column or walls. Column and walls are very, very easy to analyze, very, very fast to design too. I know that, okay? That's fine. Right now we're on 184 for the it's like something out of 383. Now, please, if you have not subscribed to our channel, please subscribe and also recommend our channel to the younger engineers, your friends and colleagues. If you're a student, share to your WhatsApp group and all that. Then also we have a global WhatsApp group where all engineers around the world shares knowledge. For example, if you're working on a design and then you not discover any error on your design, what you do is just to snap the error and then come to the WhatsApp group and ask questions. Someone that have encountered that kind of error before, that we have able to resolve the error, can be able to share how to resolve the issue for you. People also learn there a lot, so you can join the WhatsApp group, all right, and all that, and then follow to communicate with each other. So right now, you can see that it's not done with the column. Now, for the beam design, in your own case, you might see this error, this is a message, warning message. Just say yes, don't say no. Just say yes, okay? And all that. So right now, I'm beginning with the beam design. Beam design takes time a lot. So let us watch that let us see that. So I was saying that you can join the global WhatsApp group, okay, which will help you advance your knowledge and all that about structural design, because people learn both theory there. You can see someone that's you can ask a question, someone will use pen, to sketch it for you and then show you some kind of formulas and all that, which is very, very nice. Okay, so you can come there and join part of Ekidel Global Group Engineers that helps each other. Okay, that's fine. So hoping to see you there, and also please give this video a thumbs up. The more you like our video, the more YouTube tends to recommend to other younger engineers too. And also please comment if you have any kind of you are like confused in any part. Please comment too. Okay, that's fine. So right now, since the beam takes time, you can see that we are still on story 1 or story 2. I'll pause this video right now, but if I see any warning, I will unpause and then show you how to resolve that one. Okay, that's fine. Okay, so right now I can see that all the beams now have been all designed for. I can see that the beams are designed to, and also the slab and everything. And let's now go and watch and see if the members are truly designed for. Okay, when it's designed for, if I change to design interface, all the members for the column and the beam and the walls, they'll be showing green or red. Red means failure, yellow means fair failure, while green means that member is okay. So with this now, I'll go to my I'll go to my display tab and then go to do what here that says what visual interrogation. Okay, and on this now, I'll then move to display that says what load design status here. Now once I click on this now, on this, you will then see that and then say okay, that's fine. So with this, I can see that this is now the members have been designed for. Like I can see this design status here. Red means failure, yellow means warning, orange means expired analysis, green means okay, and this is that one's blue and all that. No, now you can see that all our members are what green. But I always tell you, even if your member is green or red means failure, but even if it is green, don't be happy. All right, because as a structural engineer, you are not meant to depend on the software. You are meant to check the software. So even if that is showing green, you must have to check why is this thing passing. What kind of reinforcement? What are the things that the software used to make this thing designed and all that. So you're meant to check the software and all that. So you check each of the member. Now, I have seen many people see this as a stress or as a waste of time to checking the software. Once they see that everything is green, they just they just gone to do what this drawing and report and start producing their drawings without checking the software. That is very, very bad. Don't always depend on the software. The software is there to ease your work, to make your work easier. But even at that, you still need to check the software to get to see the output the software is giving you, so that you don't have issues and all that. Because most times the software can be giving you a higher reinforcement or even under reinforcement and most times it can still show green. All right, but that's in the rare cases. But if it's for higher reinforcement, that's fine. You can see that a beam or a column that can be passing with T16, or let me say diameter 16, can go and pass with 25 diameter. That's because the that's the software's output. So you now as engineer will have to do what? Look at the member and see what is wrong, or why is this, no, this member is too small, that that this bar diameter is given. Okay, you have to now check why that thing is giving you that high diameter. Okay, so make sure you check each of your members, check them very very well before you can now say it is what okay. So after checking now, we then move to the what? Producing out the drawings. Okay, that's fine. So on our next video now will be on checking. I'll show you how to check few of the members, but use the same thing to check every members. Okay, make sure you check every members. I will check few of them and show you how to correct any error and all that, and show you how to adjust your reinforcements and all that if you're not happy on what you are seeing. All right, that's fine. So with this now, we are done with today's training, which is to do what? Run the business analysis and all that. Our next video right now will be on the math foundation analysis, which will coming up just in 2 days time, which is the math foundation. Because since we have already done the whole FE analysis, the next thing that is left now is to do what? To design for the math foundation. Okay, that's fine. So see you then on the next video. Bye for now. We love you. Bye then.